Hi, everyone. I hope you had a good weekend and are ready for this short 2-day week that you have of school. So, this week we're going to start a little bit of an algebra review for geometry, and we're going to be using our algebra skills to apply those to some geometric concepts. So, some things that you're going to need today for our notes are you'll need some graph paper. So if you have a graph paper notebook, that would be super helpful because we're going to be doing some notes too. You're also going to need a straight edge so that you can make accurate graphs with what we're working on. And you might need a calculator. Not quite sure. It depends on how your skills are with operations with integers. So some things that you're going to need. First thing that we're going to talk about today is the coordinate midpoint property. And so this is a review from what you learned in intermediate algebra. Pretty much everything that we're going to talk about today should be reviewed from intermediate algebra. Remember, you can pause the video as needed to get caught up on anything that we're working on because I already have my examples set, but you'll need to have those drawn in. So make sure that you're drawing the coordinate planes the way you see them, you're scaling them correctly, and you're drawing in segments or lines the way that you see them on the screen. Start by putting the title coordinate midpoint property on your paper. And you may recall the coordinate midpoint property tells us, or to find midpoint, you add your x coordinates together. So x1 plus x2 divided by 2. And you do the same thing with your y coordinates, y sub 1 plus y sub 2, and divide that by 2. So we have a segment on our coordinate plane here, segment LJ, and we want to know the midpoint of it. Now, I do want to review with you how to name those points at the end points for the segment, because I did notice some people doing x, y coordinates backwards. Remember, it goes x and then y, and x is horizontal, y is vertical. So you always start at the origin and you go left or right. And to go to L, we would go to the left. So we're going to the left 2, which means -2. And then we go down, so that's -6. So its coordinate is -2, -6. To go over to point J, go back to the origin, and we go to the right 5 and up 4. So its coordinate name is 5, 4. So now we just are going to substitute in our x coordinates. So -2 plus 5. It doesn't matter which one is first. We're adding them together. And then our y coordinates are -6 and 4. Remember, we're then dividing that by 2. -2 plus 5 is 3 over 2. -6 plus 4 gives us -2, and then we divide it by 2. Let's simplify that, and we get 3 halves and -1. Now let's check that with our segment. So if I start at the origin and I go to the right, that's positive 3 halves or positive 1.5. So go 1.5, and then -1. So drop down 1, and my midpoint is right there. It's right there, and it looks just like it is the midpoint halfway. 3 halves, -1. Now let's try another example. So draw another coordinate plane. For this one, I counted by 2s just because my grid was small. And my points given to me are -8, 5. So that's point A. And point B is 3, -6. Again, pause as you need to. To find midpoint, it's x sub 1 plus x sub 2 divided by 2, y sub 1 plus y sub 2 divided by 2. Don't forget to put those parentheses around it because we're still using this, calling this an ordered pair. And remember, an ordered pair goes x and then y. For my x coordinates, I would have -8 plus 3. And you could also see them right up here, right? Divide by 2. For my y coordinates, it's 5 plus -6, and then divide that by 2. So we end up with -5 divided by 2, and then -1 divided by 2. So now to check this, we're going to go over -2.5, go over negative 2.5, and then down 1/2, and it's right here, my midpoint. Now, I just told you that next week we're going to start a review of algebra skills. And so we have these sections in our book called Using Your Algebra Skills. And you're going to do, so Monday, you'll watch this video. Tuesday, you will do practice on Use Your Algebra Skills in small groups in our live class. So the first part was that midpoint formula. The second part is going to be finding slope. And so we're going to review finding slope from a table, from an equation, from a graph. Okay, so we'll look at lots of different ways. And so just to review for finding slope, remember that slope is represented with letter M. And slope is the change in y over the change in x. And I don't know if you learned this before, but I like to teach the abbreviation where you use the delta symbol. So change in y over change in x. Makes it a little quicker. So we're going to look at what is this change in y. So going from -5 to -2, the change is 3, and it's going up. So we're adding 3. From -2 to +1, from 1 to 4. That's consistent. We're adding 3 each time. So my change in y is 3. Now we need to find our change in x. My change in x, so 0 to 1, I'm adding 1 each time. It looks consistent. So my change in x is 1. So my slope is 3 over 1, or 3. You should be writing these tables down and copying down the information as we go along. Let's look at our second example. So again, to get slope, we're doing change in y over change in x. My change in y from 9 to 7 is going down 2, 7 to 5. Each time it goes down 2. My change in x from -2 to -1 goes up 1. -1 to 0 goes up 1. So adding 1 each time. So my change in y is -2. My change in x is +1. My slope is -2. And our last example, again, slope is change in y over change in x. My change in y is going down 5 each time. My change in x is going up 2 each time. So my change in y is -5. My change in x is 2. My slope is -5 over 2. Now, what if we have an equation and we need to find the slope? So you know the slope-intercept form, y equals mx plus b. So m is our slope, b is our y-intercept. So looking at my equation here, y equals -3x plus 4, I can see that my slope is -3. My y-intercept is -4. Looking at my next equation, y equals 5 times 1 minus 2x. So before we can figure this out, we have to simplify. We're going to have to distribute that 5. So y is equal to 5 times 1 minus 5 times 2x. Now, some of you maybe don't need me to write that out, but I'm just showing you just to make sure you remember how to distribute. So y is equal to 5 minus 10x. Now I can rewrite that. Y is equal to, that minus 10x means that 10x is negative. So -10x, and that 5 is positive, plus 5. And now this looks more like y equals mx plus b. So my slope is -10. My y-intercept is 5. Let's look at this last one. So this one's given to us in standard form, ax plus by equals c. So we have to get y by itself to get in slope-intercept form to get the slope and the y-intercept. So the first thing I would do is subtract 8x from each side. Now be careful here because that's minus 3y. So that means that I bring down negative 3y. And now I have negative 8x plus 4. You could do 4 minus 8x, but I already know that I want it in the form of y equals mx plus b. Divide both sides by 3. That means everything on the right side gets divided by negative 3. Y is equal to negative divided by negative is positive. So y is equal to positive 8/3 x plus or minus. If you do plus, it's negative 4/3, or you could do minus 4/3. Your slope is 8/3. Your y-intercept is negative 4/3. Now, let me caution you here. Your slope is 8/3. There's no x with slope. X is a variable that we don't know its value. The slope is rise over run. So your slope is only 8/3. If you put x on your slope, it will be wrong. Okay, so your slope is 8/3. The same with the previous problems. Your slope is negative 10, not negative 10x. That x is an unknown. It is not your slope. It's being multiplied by your slope. Up here, with the first one, your slope is negative 3, not negative 3x. So there is no x with your slope. Now, finding slope from 2 points. So when we find slope from 2 points, there's lots of ways you can do it, but this is the easiest without graphing it, is you take your change in y over your change in x, just like what we did when we were talking about slope before, right? Change in y over change in x. But we do y2 minus y1 over x2 minus x1. You may have learned, I have seen this in some books, where they write it as y1 minus y2 over x1 minus x2. You know what? It doesn't really matter as long as you decide which one is your first set, which one is your first coordinate, and which one is your second. So let's start with this first one here. So this would be x1, y1, x2, y2. So for slope, let's just do the first one. So remember, it's always y, change in y over change in x. So we're going to do 1 minus 6, y sub 1 minus y sub 2, and then x sub 1, 3 minus 7. 1 minus 6 is negative 5. 3 minus 7 is negative 4. Don't leave it like that because a negative divided by negative is positive. So your slope is positive 5/4. Let's look at the second one, 3, 1, and 7, 1. So this would be x sub 1, y sub 1, x sub 2, y sub 2. Remember, we're doing change in y over change in x. So that means y1 minus y2, x1 minus x2 in the denominator. So for my y's, I'm going to have 1 minus 1. And then for my x's, I'm going to have 3 minus 7. 1 minus 1 is 0. 3 minus 7 is negative 4. Now think about that. So if you have a point and you cannot go up 0, you cannot go up 0 and then you go to the left 4, you're going to have a point here, right? You go up 0 and then to the left 4. So you end up with this horizontal line, right? So you end up with a horizontal line for this, for your slope. So what would that be called? That would be 0 slope, okay? I don't know if you ever watched Slope Dude, but that's when he's just on the flat surface and he says, this is 0 fun. All right, let's try our last one. So again, change in y over change in x. So we're going to have 1 minus 6 and 3 minus 3. This time you get negative 5 over 0. So let's think about that. If you have a point and you are going to go, remember it's rise over run, so you go down 5 over 0 point. Down 5, you can't go over. You end up with this vertical line. That means it's undefined. And as Slope Dude would say, he would go undefined as he goes off the cliff. Now, finding slope from a graph, you just count rise over run. So if we have 2 points, so draw this graph And then I've got 2 points marked here. I'm just going to connect them with a line. There we go. And we just count rise over run for this. So remember, rise, that's our change in y. Run is our change in x. So from this point, so I'm just going to count how many spaces up am I going? 1, 2, 3, 4. Remember, I'm counting spaces. So I went up 4. That's positive. And then I'm going to go to the right, and I went 1, 2, 3, 4, 5. That's positive 5. So that change in y over change in x would be 4 over 5. And you can check that because this slope is going up, so that means it has to be a positive slope. So you can check to make sure that you did indeed get a positive slope. Now, what about if you have a word problem or context and you need to find slope from the context? So like in this first problem here, what is the speed in miles per hour? Well, we do have some points on our graph here. But now look at the scale. So my hours are labeled by 2s, and then my miles are counting 100, then 300, then 500. So they're counting every 200. So if I go from this point here, this is 200, and I go to this point up here, this is 400. So again, thinking about that rise, I'm going up. So I'm going to go up 200. And then my run, I'm going over 3. So my slope would be 200 over 3, or 200 miles in 3 hours. You could simplify that to figure out how much that would be per 1 hour if it was asking for a unit rate. Okay, if we were looking at the second example, which inline skater is faster, you could find the slope for each one. So again, you would be doing rise over run. So it's going to be meters to seconds. That's what we're looking for, meters to seconds. And so if I go from this point to this point, I'm at 15 up to 30. So that's plus 15. And then I'm going to go over, let's see, it's 5, 10. So it's looking like 2.5 to 5. So 15 over 2.5. So 15 meters for every 2.5 seconds for this first one. If I look at this one, my second skater, I'm going to go up from 10 to 20. So that's plus 10. And so I'm going up 10, and then I'm going to go over 5. So 10 meters for 5 seconds. Well, that's kind of hard to compare, but let's think about if we wanted to think about proportionality, and I wanted to know how far the skater 1 goes in 5 seconds. They went 15 meters in 2.5. That would mean they go 30 meters in 5 seconds. So it sure looks like they are faster. Now, we're going to talk about what happens when we look at slopes of lines. And so what I want you to do right now is draw a coordinate plane. And I've got some points here. So point A is -1, -2. I want you to label that point. Point B is +1, +2. And then connect those points to make a line. Point C is -2, 0. And D is 0, 4. Label those points, connect those points to make a line for CD. We're going to find the slope for AB, and lots of ways. We've looked at lots of ways to do this. The easiest right now, since we have a graph, is that we can just count. So we can count our rise over run, and that means we're going to go up 1, 2, 3, 4. So change in y over change in x. So we're going up 4. And then we're going to go over 2. So 4 over 2, which is 2. And then for CD, we'll do similarly. So we're going to count we're going up 4. And then we go to the right 2. So add 2. 4 over 2 is 2. And what do you notice about lines AB and CD? They're slopes. They have the same slope. And these lines are also parallel to each other. Now let's look at these points 0, -4. So draw another coordinate plane. Label point A, 0, -4. Point B is -1, -7. Point C is 3, 0. And point D is -3, +2. And I had to go off of my grid a little bit to get point B on here. All right, so now we're going to find the slopes of AB and CD. So for AB, remember B was -1, -7, and that's important for me because I went off my grid. So my change in Y, I'm going from -7 up to -4. So that means I'm going to go up 3. And my change in X, I'm going to go up 3, and I'm going to go to the right 1. So +3 over 1. So my slope is 3. Now for CD, I'm going to go from D to C. So I'm going to go down 2, and I'm going to the right 6. So I have -2 over 6, which is -1/3. Let's think about those as fractions. So line AB and line CD are perpendicular to each other, and their slopes are opposite. One is positive, one is negative. Reciprocals. It's very important that you have both of those parts, opposites and reciprocals. Reciprocals is where the fractions are flipped upside down. So where we had 3 over 1, here we have 1/3. All right, the last thing we're going to do is write down the parallel slope property and perpendicular slope property. The parallel slope property says in a coordinate plane, 2 distinct lines are parallel if and only if their slopes are equal. So remember, parallel slopes have to be equal, or they're both vertical lines, which in case they were both vertical lines, then they would both have a 0 slope. They would both have an undefined slope, vertical lines. Perpendicular slope is in a coordinate plane. 2 non-vertical lines are perpendicular if and only if their slopes are opposite reciprocals. Remember, it has to have both opposite reciprocals of each other. So they have to flip the fraction, and one is positive, one is negative. Tomorrow, we will do some practice with this in our book assignment. So make sure that you have gone through the entire lesson and you have gotten all the notes down so that you are ready for that tomorrow during class. I'll see you then.